American Motors Sales Corporation presents Why Volts, Ohms, Amps, and Meters. It's an in-dealership service training program that will give you the right answers for expert diagnosis and repair of the various electrical systems on AMC cars and Jeep vehicles. What 3 easy-to-use meters are important for proper electrical diagnosis? What easy-to-understand facts on basic electricity will help you use the meters correctly? What symptoms signal possible malfunctions in a vehicle's electrical system? And how you should use meters to accurately diagnose electrical problems. 2 learning aids are used, this film strip and a reference book. The film strip tells you the basics about volts, ohms, amps, and meters, and the reference book gives detailed information for expert electrical diagnosis and repair work. Programmed learning will help you understand and remember the important facts. This is done with a brief review of key ideas immediately following each training topic. Let's begin by answering the most important question you might have. Why should you know how to use meters for electrical diagnosis and repair? Especially when most of the time you seem to get along fine using a test lamp and jumper wire. A previous training program showed you the value of these simple troubleshooting tools. But as you know, a test lamp and jumper wire can only tell you so much. They test completion of the electrical circuit. They cannot tell you about the quality of the circuit and the various loads. Meters let you test quality. In this program, we'll discuss 3 meters that can help you quickly diagnose the most troublesome, hardest to find electrical faults. All tests will be made without the engine running and the battery as the only power source. The voltmeter, the ammeter, and the ohmmeter. These are the 3 basic electrical test meters you should know about, how they work, and how you can use them. The voltmeter reads the difference in voltage or electrical pressure between 2 points in a circuit. It would measure the electrical pressure of this battery in volts, much like the gauge that checks pounds per square inch of water pressure at the bottom of a tank. The ammeter reads amperage or current flow in a circuit. It would measure the current flow in this wire in amps, much like the gauge that checks gallons per minute of water flowing through a pipe. And the ohmmeter reads resistance to current flow in a circuit or working load. It would measure the resistance of this indicator bulb in ohms. 1 ohm is the resistance that will allow 1 amp to flow when the electrical pressure is 1 volt. Let's make sure we've got it right though. This quick review will help make sure you know the 3 electrical test meters that can help you most. Match the meter to the type of electrical measurement. A voltmeter measures electrical pressure in volts. An ammeter checks current in amps. And an ohmmeter reads resistance in ohms. Now, with the meters to measure them, let's see how these ohms, amps, and volts can help you be an expert in electrical diagnosis. How voltage, resistance, and current work together is easy to understand. This simple circuit proves it. The rule is 1 volt of pressure against 1 ohm of resistance will cause 1 amp of current to flow. For higher current flow, you must have either more pressure or less resistance. For lower current flow, you must have either less pressure or more resistance. The rule is Ohm's law. Amps equal volts divided by ohms. Volts equal amps times ohms. And ohms equal volts divided by amps. To make it simple, this circle diagram will help you remember Ohm's law for use in your work. An easy way to use this circle is to think of the line as a seesaw. If you know the voltage is good, but current is up, the resistance must be down. This could mean you have a short circuit which bypasses a working load. Or, with the same voltage, when current is down, resistance must be up. This could mean you have a bad connection. These facts about volts, ohms, and amps are important, so let's stop to review what we've learned. In a simple horn circuit, battery voltage of 12 volts is applied to the horn. The horn has a resistance of 3 ohms. What would be the current draw? The current, of course, is 4 amps, 12 volts divided by 3 ohms. Now, think of the rule for volts, ohms, and amps. With no change in voltage, what happens to current when resistance goes up because of a bad connection? Use the seesaw. When resistance goes up, current goes down. We'll now look at how voltage and current work in 2 commonly tested circuits, the series circuit and parallel circuit. This series circuit is for the dash lamps. With the headlamp switch on, current flows from the battery through the rheostat, then to the bulb to ground. Simplified, the circuit would have voltage applied against 2 resistances, the rheostat and the bulb. Current is the same through each load. It has only one path to ground. The voltage across the 2 loads is different if the resistances are different. For instance, if the battery voltage is 12 volts, the rheostat 16 ohms, and the dash lamp 8 ohms, the current would be 1/2 amp, 12 volts divided by 24 ohms. The voltage across the rheostat would be 8 volts, 1/2 amp times 16 ohms, and across the dash lamp it would be 4 volts, 1/2 amp times 8 ohms. The 2 voltages, of course, equal the battery voltage. Now, let's see what happens with voltage and current in a parallel circuit, such as that used for AMC and Jeep headlamps. For our discussion, we'll leave the switch out and apply battery voltage to the circuit. Unlike the series hookup, current now has 2 paths to ground. Current flows from the battery through each headlamp to ground. Current can be different in different parts of the parallel circuit. Voltage, however, has to be the same. Each load sees the same pressure. In our headlamp circuit, let's say the total current is 4 amps. With the same resistance in each headlamp, current would split to 2 amps through each path. The resistance of each headlamp would be 6, 12 volts divided by 2 amps. To help you remember how voltage and current work in the 2 circuits, check your progress on the basic facts. First, make sure you know the circuits. Does each load in the series circuit see the same voltage? Does each load in the parallel circuit see the same current? Both answers are no. Voltage may be different across each load in a series circuit, and current may be different in each part of a parallel circuit. Sometimes these circuits don't work the way they should. Let's take a look at the possible problems. When something goes wrong in a vehicle's electrical system, there are 6 possible faults you can look for: loss of power, an open circuit, a short circuit, an unintentional ground, high resistance in the circuit, or a defective working device. The first and last are obvious. You may not be getting enough power from a run-down battery, and a defective device might be something like a burned-out bulb. An open circuit is simply a break somewhere in the circuit. Even with voltage, if the circuit's not complete, current cannot flow. A short circuit is a path for electricity that wasn't designed in the system, but happens accidentally. For instance, sometimes 2 circuits touch, so that both function whenever either is turned on. A short circuit could blow fuses or trip circuit breakers if the combined load in both circuits exceeds the rating of the circuit protection. An unintentional ground means that some current flow is accidentally sent to ground. If a load is bypassed, resistance goes down and current goes up. This can overheat wiring, blow fuses, or trip circuit breakers. A high resistance fault is often the hardest to find problem in a vehicle's electrical system, and this is where meters are the most valuable for accurate diagnosis. High resistance can be caused by loose, dirty, or corroded connections. Current flow will usually be below specs. Remember the symptoms that signal each malfunction, such as high or low current or none at all, and you can quickly diagnose the fault. Let's see how. The headlamps in this circuit will not light because a screw has been driven through the harness and is touching car metal. What type of electrical fault is this? Open, short, unintentional ground, or high resistance? The answer is unintentional ground. There is no current at the headlamps and no wires are disconnected or broken, so the current must be flowing to ground, the car metal. Now let's concentrate on the 3 meters and put what you've learned to work. First, always make sure the meters you're using are accurate. Most meters can be zeroed by turning a small screw until the needle on the face lines up with the zero mark. The meter should not be connected to a circuit when you adjust the screw. Always set the meter range adjustment for a voltage or current higher than you expect to find. If the needle deflects less than half scale, set the range adjustment 1 step lower. This will help keep the meter accurate. For example, 12 volts applied to a voltmeter set for 4 volts will peg the needle and damage the meter. Next, know how to connect the meters. This is a voltmeter hookup. Always across, in parallel with, the load or circuit. No voltage might indicate an open, and low voltage might mean you have a high resistance, corroded connection. This is how you connect an ammeter, always in series with the circuit, with the positive side toward the voltage source, negative side toward ground. Like a voltmeter, the ammeter can also tell you several things. No current, of course, would mean an open. A high, out-of-spec reading could indicate a short or unintentional ground. And if current is below specs, a high resistance fault is the cause. The ohmmeter can only be connected across a circuit or device with the power removed. This meter has its own battery and will be damaged if connected to a circuit that has power applied. A zero reading indicates a possible short or unintentional ground. An infinite reading, like a sideways 8 on the meter, says you have an open circuit. And a reading out of spec could mean the device is defective or you have a high resistance loose connection. Again, let's stop for a moment and make sure we all know how these meters are hooked up and what they can tell you. Which 2 meters in this circuit are connected wrong? The voltmeter and ammeter were hooked up wrong. Only the ohmmeter was right. Remember, voltmeter across the load with voltage applied, ammeter in series with the load, ohmmeter across the load without voltage applied. Now, refresh your memory on how a high resistance fault can be diagnosed. There are 3 meter readings you can use. What are they? The answer's easy. When you remember how volts, amps, and ohms work together in a circuit. Low volts and low amps could mean you have high resistance. And high ohms, of course, pinpoints the exact problem. You're now ready to go to work. Let's see how you can use these meters for diagnosis on several circuits being used in AMC cars and Jeep vehicles. We'll use this simplified headlamp circuit to show how a voltmeter can find a high resistance problem. The owner complaint would be dim headlights or possibly occasional failure. Start by connecting the voltmeter black clip to a good ground. You can then connect the red clip anywhere in the circuit to check for a loss of voltage. Use common point testing and you'll easily find the cause of low voltage to the lamps. For this example, we'll take measurements on the headlamp side and battery side of the dash connector. Starting at the lamp ground connection, you should have 0 volts. Voltage would indicate a poor ground. Next, check the lamps at their connectors. In this case, we only have 6 volts. And while checking for voltage at the dash connector, we still find only about 6 volts being fed to the lamps. At the battery side of the headlamp switch, however, we get a reading of about 12 volts. This tells us 6 volts are lost across the switch, the point of high resistance. What could have caused the high resistance problem in the headlamp switch? The answer is all 3. First, check for a loose connection and repair it if necessary. Then, clean the switch or replace it if needed. Now, let's look at how you can use an ammeter to diagnose why a tail lamp circuit is blowing fuses. Like the headlamps, the tail lights are on a parallel circuit. Go to your wiring diagram and you'll see that current flows from the battery to the fuse panel, then to the headlamp switch, through the body harness connector to the tail lamps. For easy access to the circuit, connect your ammeter to the fuse panel with the tail lamp fuse removed. Remember, red lead toward the power source, black lead toward ground. Fusing for the tail lamp circuit is 14 amps. If you get more, that's why the fuse failed. The real reason, of course, is that there's probably a short or unintentional ground somewhere in the circuit. Check the circuit using common point testing until you find the problem. Let's say you fix the problem and the owner wants to add a trailer towing package. This will give you more fusing problems unless you use your ammeter and find the total current you have to fuse. The trailer tail lamp circuit is added in parallel to the car lamp circuit. This causes higher current flow, usually about 18 amps total. Your ammeter will show that you need a larger fuse. About 20 amps would be right. Back to our original problem. Which 2 of these caused the fuse to blow? Just remember the seesaw rule of how current and resistance work. Current was up, so resistance had to be down. That's easy to understand because the short or unintentional ground bypassed the lamp in the circuit. For our third meter, the ohm meter, let's look at several areas of use. You can verify a high resistance diagnosis, remove the power source, and check an entire circuit for continuity. Measure spark plug wires for proper resistance, anywhere from 3,000 to 25,000 ohms, depending on the wire length. And measure the sensor resistance in the BID ignition system from about 1.5 ohms to 2.5 ohms. Remember, though, you cannot have any voltage in the circuit when using the ohm meter. We've disconnected it here for this high resistance test and continuity test. After you've disconnected the voltage source, just connect the ohm meter across the terminals of the component you want to check. Here's how you would check the resistance of the spark plug wires and BID sensor. As a final reminder, do you remember why voltage should be removed from the component you're testing for high resistance and from the circuit you might be testing for continuity? Which of these is the best answer? Number 3 was the answer. Voltage must be disconnected from the circuit because it will damage the ohm meter. All 3 test meters can help give you the right answers for expert electrical diagnosis. But remember your facts on basic electricity and how you should use the meters. Also, remember to use the film reference book and your technical service manuals to help in your diagnosis work. Now that you have the answers to why volts, ohms, amps, and meters, you have the right answers for expert diagnosis and repair of the various electrical systems on AMC cars and Jeep vehicles.